So this is talking about the how, or the what to do. Now, some of you are statisticians, perhaps. Some of you have examples and experience of doing survey size calculations for other surveys, and you will have maybe used some other methods. So I'm going to make one or two or three more videos later today or tomorrow to address those of you who are experienced and who are wondering, why in this new manual, why do they not use the same method as DHS? Why do they not use the same equations as mix? Why do we not use the same method as the old WHO manual? Why is this new method better than the method from 2005? So for those of you who want to know not just the what, really to do the homework this week, you just need to know the what. You need to be able to find A, B, C, D, and so on, and work with them together. And you don't need to know the why. If you want to know the why, then I will be happy to correspond about it, but I will make a few videos to address some of the why as well. And those will be bonus videos. You don't have to watch them to do the homework, but they will maybe satisfy your curiosity. So for the remaining time, I would like to go through some slides that are based on a true story. I have changed the numbers a little bit, but a few years ago, we wanted to pilot the new survey methodology, and the expanded program on immunization in Burkina Faso was gracious enough to partner with us to do a pilot survey in Burkina Faso. They had just had a measles vaccination campaign, and they were curious about the coverage that was achieved in the campaign. And so we began to have the discussion with them about what should the goals of the survey be, at what level of strata should it be accomplished, and then what should the sample size be. And so we're going to look at 5 different scenarios in the next few minutes in our remaining time for Burkina Faso. And we will calculate what would be the required sample size for each of the 5 scenarios. We will change some parameters after the first scenario. So you know this is Burkina Faso in West Africa. And as we said a few moments ago, if you want to have results below the level of just national results, then if you want to have some subnational results, one logical set of strata might be administrative regions. So there are 13 administrative regions in Burkina Faso. And another logical level of strata might be the health districts, because the vaccination program is administered at the health district level. So there are 3 obvious options for strata, and there are trade-offs here. The simplest, least expensive survey, fastest survey would be to do a single survey to estimate post-campaign coverage for the entire country. You'd have one number. Say coverage was 92% for the whole country, but you would not have any subnational detail. And so it would be difficult to take action. We know that for a measles campaign, the goal is 95% coverage. So if we had a number like 92 or 91 or 87, it's not very actionable. So we could go a little deeper. We could do a survey that's more expensive and gives results that are more detailed. I'm using the word granular here. And, we would have more. We would have a result. We would have 13 results. And then we would be able to aggregate those 13 results, one for each region, up to the national level, and have national level results also. But of course, it would be more costly. And in this case, the Ministry of Health said, well, 13 is better than 1, but we really would like to have more granularity. We would like to have results at the district level. We have an EPI review coming up, and we would like to have some results at the health district level. So the pros are that the results are very granular, probably actionable. The data can still be combined to calculate regional coverage and to calculate national coverage. But of course, there's a high workload and cost. And as you expand the amount of work to be done, then there's a very real challenge for how do we maintain high quality work? How do we know that we are hiring people who are going to take this very seriously and do the extra work that is required to do a high-quality survey. So there's some trade-offs there. So when we first started talking to Burkina Faso, the goal was to measure post-campaign coverage, pardon me. And so we could even begin to fill in these results after the first discussion, and then some of them were going to require some calculations in order to fill them in. So we're doing a post-SIA coverage survey. The target coverage is 95%, and we worked with the folks in the Ministry of Health to say that we want a confidence interval no wider than plus or minus 5%. We want results in every district. So results in every district means the number of strata is 63. The target age range, the campaign was for kids 9 months up to 15 years. And so we had some professionals there who could tell us that, yes, you'll find a child in that age range on average. Probably almost every home will have a child that age in it on average. And so every home you visit, you'll find an eligible respondent. And they decided that probably 10 completed responses per cluster was a reasonable input. So we know that little m is 10 here. And they said, let's assume from the start that 5% of the eligible respondents would either not be at home or might refuse to help in the survey. So we have 3 of the 6 values that we need. And in the next few steps, we'll do some calculations to fill in the rest of this table. Okay? And then we'll use those numbers to calculate the sample size. So the first empty slot here is the effective sample size. We have what we need to calculate it. This is what we need. The target coverage. We're doing a survey for estimation. We have the target coverage and the desired confidence interval width. I see the question going by, what is a cluster in this case? Clusters in this case were going to be census enumeration areas. And that's an important part of the discussion. That's not so much part of the sample size chapter or calculation, but it's a very important part of the discussion, which is what's the sampling frame that's available. This will come up for your concept note. And what will the clusters be? Will they be villages? Will they be defined on some kind of a grid? In this case, there are census enumeration areas. Okay, so let's calculate the effective sample size. We're going to go to table B1, which is in your annex, and we just go to the intersection. Target coverage is 95%, and we want a confidence interval no wider than plus or minus 5%. And so the effective sample size given by the table here is 162. And so we can go back and fill in 162 here in this cell. Okay. And now we need to calculate the design effect. And again, we have we have the number of respondents per cluster. This is in talking with the person who will be the survey manager, likely the survey manager, thinking about how long do we want the team to spend in the cluster. And so we came up with a number of, if we use 10 respondents per cluster, we don't have a value for the intra-cluster correlation coefficient, so we just use the recommended value here for an SIA survey, which is 1/6. And so the intersection here is to use a design effect of 2.5. Okay, so we could fill in 2.5 for the design effect. So we use these inputs to calculate the effective sample size using table B1. And then we use this input and the knowledge that it's an SIA survey to calculate the design effect. And now we just need to calculate the inflation factor for non-response. And we can use table E. The tables are named after the value. So this is value E, so this is table E. We have been told by some survey professionals to expect probably a 5% non-response rate. And so that means that the inflation factor will be 1.05. And we will see when we go to Excel, this is truncated to a small number of digits. In Excel, it uses more digits. In Excel, we put in the response rate, which would be 95%, and it will give us a slightly different number here. So now we have the table completely filled in. These are the inputs for the sample size calculations. We take these numbers and we go to the worksheet that's in table on page B111, and we write those numbers across the top of the worksheet. I didn't show you the top of the worksheet here, but it just looks like a table like this where you write the 6 numbers down. And then there are 6 equations on the worksheet. This is the worksheet, and indicates very clearly which quantities to write into the equations to calculate the 6 useful values that the budgeting team will need, or the logistics team will need. So how many households would we need, or how many completed interviews would we want? What would be our target sample size for the data set of completed interviews when we are done? Well, the effective sample size was 162. We inflate it by the design effect, and then we multiply that by 63 surveys. So for this scenario, we are talking about a final data set with 25,515 completed responses. How many households would we need to visit to get that many completed responses? Well, we know that we'll find an eligible child in just about every house, but we have to inflate the number of houses to go to by a small amount because in some houses, the respondent will not be at home or will refuse. So to get 25,515 responses, this second equation is telling us we would need to go to about 26,791 households. The households to visit in each stratum would be 426. Again, we just plug in B, C, D, and E here, multiply, and round up. 63, I see the question in the chat there. 63 is the number of strata. So this is quantity A. And so if you look here, A, B, C, D, these are all these quantities here. And then in this case, we have NCS. That's because that's using the nomenclature that this is a number that we've already calculated up above. Okay, and then 3 more equations at the bottom part of the worksheet. How many clusters would we have per stratum? It would be B times C over M, 41. How many households will we need to visit in each cluster? Well, we want 10 completed responses, and we think in about 5%, no one will be home. So we round it up from 10.5 to 11. So we would visit maybe 11 households in each cluster. And then how many clusters in the survey? This is very important for costing and planning. How many places are we going to have to send survey teams? In this case, it would be 2,583 clusters. There's a certain cost to sending a team to a cluster, and so this is one of the cost drivers. So these 6 numbers are the numbers that we would pass forward to the logistics and budgeting team. This is the output. This is the result of the sample size calculation, these 6 numbers. Now, I'm going to, in real time, show you how to get those numbers with Dana's spreadsheet. We are doing a survey for estimation here, so we're going to choose the tab called Estimation. There's results here for 3 scenarios. This is just scenario 1. So the number of strata that we selected for this exercise was 63. The cells that are bordered in blue are the cells that you should type into, and the cells that are bordered in gray or black, they will be calculated when you have entered enough inputs. So we're going to skip effective sample size because it's going to be calculated here. The expected coverage is 95%. So we entered this as a decimal. Yes, see, I see here we're going to have to change this because this value should be allowed to go up to higher values than 0.95. So we'll definitely be giving you a revised version of the spreadsheet later in the week. To do your homework, this is sufficient. But for life, we want this value to be able to go up a little higher also, I think. And the half width of the confidence interval is 5%, so that's 0.05. As soon as I populate this cell, I think we will see that the effective sample size, and what is alpha? Alpha is also 5.5%. Now, we have the same value for alpha that we had from our table, from table B1, 162. To calculate the design effect, you can simply type it in if you know it, but if you want to calculate it, in this case, 10 respondents per cluster. And, oh, no, I used the wrong. This is 10 respondents per cluster. So there you saw a helpful error message. And here the ICC is 1/6. And this gives us our design effect. So that's value C. And then down here, the number of households to find an eligible respondent we said was 1. And in my instructions in the video, I told you to type a number in row 32, but then we locked row 32, so you can't do that. We will give you a revised spreadsheet later in the week that has this unlocked. But if you enter this response rate in row 34, 0.952381, then you get the non-response inflation factor that we're looking for here, 1.05. And I use this rate so that these numbers will match what we're doing. If we use 0.95 here, then the numbers are a little bit different. But so for today, we will use this number to show that if you typed in 1.05 here, if you typed in the value from table E, then these values, these outputs, are exactly the same as what we calculated on the worksheet. If we go up here, 25515, 25515, 26791, 26791, 426, 426, and so on, 4111, 2583. 4111, 2583. So the only small point of confusion between the table and the spreadsheet is that in this table, when we made this table, we truncated this number to two places after the decimal point. So if I say that the response rate will be 95%, so the non-response rate is 5%, here I'm telling you to use 1.05. In Excel, we have not truncated it. If you put in 95 here, then instead of getting 1.05, we get a number that is slightly different up here. And so this number would differ a little, and this number would differ a little. When you do your homework, you may do it either way. We'll give you a version of the spreadsheet that unlocks row 32, and then you can type in 1.05. Or you can just type in 0.95 here. Or you can type in this factor, which gives you 1.05 here. So there will be 3 different ways you could do it. So that's just to illustrate that the spreadsheet is giving the same answers as the worksheet. So if we decide that that's very expensive and maybe not affordable, then the next round of conversation might say, oh, golly, we cannot afford 63 strata. What can we do? Maybe we will do the survey in 13 strata. So if we use the spreadsheet and we change the 63 to 13, we leave everything else alone. Then, because Dana has given us 3 columns here to compare, we can see what is the effect. Now, instead of needing 25,000, let me make this a little bigger. Instead of 25,000, now we need only 5,000. Instead of visiting 27,000, we will visit 5,500. And instead of sending teams to 2,500 clusters, now we will send teams only to 533 clusters. So this is an example of possible compromise in the sample size, in the scope of the survey, but it means that rather than having 63 actionable responses in each district, you have 13 responses in each administrative region. You have some detail below the country level, but not as much as you might want. For these 2 calculations, the goal was to estimate vaccination coverage from the measles campaign. But then in real life, this really happened. I have a very reasonable conversation to say, oh, if you are going to do a survey in every health district, then some of the children that you will interview, they will be 12 to 23 months. This is the traditional age where we do a routine immunization survey. So could you also maybe, in addition to asking, was this child vaccinated in the recent measles campaign, could you spend just a few extra minutes and also ask about their routine immunization coverage? Could you ask to see their routine immunization card? Could you write down the information from the card, and we can also calculate not only campaign coverage, maybe we can calculate routine immunization coverage. And in real life, in Burkina Faso, they said, in this coming year, we expect to do a thorough routine immunization program review. We would love to have guidance for how is the performance in each health district so that we can take steps to learn from those who are doing well and to improve those who are doing less well. Could we maybe do this? And this is a common part of the conversation early in the survey process, to say, if you are going to spend the money to visit all these people, can we also ask them a few extra questions and get some additional information? Because the person will look at you with big eyes and a sweet smile, and they will say, after all, you're already going to go there. You're going to be in the house. It's just a few more questions. Could you please ask my questions also? Well, we have to think about it. Before we give a response, we have to think
Dale?
that, yes. Is that you, Carolina?
Yes, just because I see a lot of questions in the chat, maybe before we go to the scenario of adding the RI, maybe if you could recap a few questions that were asked.
Yes.
And maybe re-walk people through the formula or the Excel. Okay.
Yes, so let me go back and look at the questions here.
And maybe, Dale, if I can add a corollary question, if people want to go back and review, do you have a suggested approach for how to sort of work through these calculations that you've seen work for other people to sort of wrap their heads around what they are doing by working through this calculation?
Yes, so if you want to know the details, and I should have mentioned this at the top of the call, if you want to know the details of what, how were these tables constructed and what are the equations that go into these tables, those equations are all available in Annex B2. So to do the homework this week, you do not have to even look at Annex B2, and you don't even really have to understand where did the numbers come from. But many of you will want to understand where did they come from. And so the equations that were used to make the tables are all in B2. Or if for some reason, if you lose your copy of Annex B1, you can still do everything you need to do by putting the numbers into the equations in Annex B2. So if you didn't have the tables available, you could do the calculations using B2. So all you really need to know is to assemble these numbers and multiply them together on the worksheets in the way that is shown. But if you want to know more, then you'll want to watch the videos that we've provided and maybe spend some time absorbing Annex B2. So I see a question, what is the exact sample size? So we will go back. So the sample size in terms of the number of completed responses that we want to have, that's the first quantity that we calculated here, 25,515. That's what we expect for completed responses. But to estimate the budget for the survey, that number alone is not adequate. We need to know, what does it take to get that many responses? In this case, the number of households that you have to visit is very similar. It's only inflated a small amount from the number of responses you want. But we will see if we move on in a few minutes to the routine immunization calculation. If you are interviewing a population that is quite rare, like children with a 1 year age window, then you have to visit more homes, and you have to visit quite a few more homes to get to the sample size. So the sample size is A times B times C. That will be the sample size in the data set. But these other quantities are telling you what is it going to take to deliver that sample size. How many clusters will I need to go to? This is an important number for costing purposes. How many households will I need to visit in each cluster? This is an important number for workload planning. How big do the teams need to be? And so on. When you're estimating coverage for all routine X vaccines, do you choose a tracer vaccine to input the desired coverage in the Excel sheet? Yes, you do. So you have to select a primary outcome. It's usually DPT3, not usually DPT1, that we use as the primary outcome for the sample size calculation. Let's see. If you have no idea what coverage to expect, would you enter 50% because it's the worst case scenario? Yes. Although these days it would be very rare to be working in a place where you have literally no idea what to expect. That was often the case in the 80s, but now it would be quite rare for vaccine coverage in any country that we're talking about to have, unless perhaps after some sort of trouble or war or disruption, or it can happen. So if you do truly have no idea, then you could enter 50. I see one person says that the number of strata can only go up to 50, so that means you have downloaded the first version of the spreadsheet that was uploaded. Rita sent a link to a newer version of the spreadsheet. Not possible to type in 63, so that's okay. To do the homework this week, you'll have to type in 100, so you'll need to obtain the newer version of the spreadsheet. I think Carolina maybe put it in a link in the chat. Let's see what else we have here. Coverage can be different. This is a great question, Jose. Coverage can be different for the province and different for the national level. What coverage do we use in the table? So I have said to you very simply what is the expected coverage here. But if you were doing 13 surveys in 13 administrative areas, if you already know before the survey that coverage in some areas is higher and some areas is lower, instead of doing one sample size calculation, you could do a sample size calculation for each of the regions of the country where if you know that coverage varies. That would be one way to do it. The other way to do it would be to select the most conservative coverage value, and the most conservative one, as pointed out by one of the other participants, is the one that is closest to 50%. As you see here in the table, as you go closer to 50%, the sample sizes get bigger in every row. They are biggest at 50%. And it would be true if we included the numbers below 50% also. They would be getting bigger as we go close to 50%. So if you have either different vaccines that you're interested in, you might pick the one with the expected coverage closest to 50%. And if you have good reason to believe that coverage varies in different parts of your country, then you have two choices. You can do you can do a sample size calculation for each part of the country. That's what I would do. Or you can say, oh, that's too complicated. I'm going to do the most conservative calculation, and then we will do a survey in every part of the country that meets the needs, the most conservative part of the part of the country that's closest to 50%. In that case, you are doing a bigger survey than you need, probably. So here's another question from Pamela. If going to each district is too expensive, can you select a few of them? That's a great question. The answer is yes, you could select them, and you could select them in a couple of different ways. You could do a random selection, in which case you could still calculate an estimate for national coverage. If you did a probability sample of districts and then did a sample in those places, that would be more advanced than we cover in this manual, but we would be happy to talk about how to do it. It would be more likely, if you're only going to go to some districts, probably the Minister of Health, the Administrator of Vaccination, they have some idea of what are the places where we likely have some problems. And so we would say, let's go to those places. Let's go to the worst places and find out what is going on and how can we help. If you select the districts in a purposeful manner, not a random manner, then you cannot use them to calculate national coverage figure. So if you go to every district, you can calculate a national coverage figure as well as the district level. If you go to a random sample of districts, you can calculate a national coverage figure. If you purposefully decide to go to the worst of the worst, then you will have excellent information there, but you will not have an estimate of national coverage. Carolina says, let's remember that this is recorded and you have the materials. The direction of statistical power. There's no direction. For estimation, there's no direction of statistical power. So in this case, we're estimating a two-sided confidence interval, and there's no direction. Later for classification, there is a direction. But in what we've talked about so far, there's no direction. We're estimating a confidence interval with a particular precision. Why not more? Why 10 as the parameter? Why not more kids per cluster? So there is a tension for cluster surveys. It's always better statistically. Statistically, we would like to do a simple random sample because that's how you gain the most information for the fewest respondents. If you had a current list of all the kids who are in the country, and you could select children randomly from that list and then send out teams to interview only those selected children, that would give you the most statistical precision for the smallest sample size, or close to it. But we're going to do a cluster sample because it's much more cost effective. Once you've driven out to a particular location, it's cost effective to interview not only the first child, but to interview some children who are neighbors as well. But those children, the other children that you interview, they don't tell you as much as the first child did, because when kids that live in the same neighborhood, they are likely to have the same vaccination status. They have the same access to vaccination services. They have the same socioeconomic status. They have the same influences in terms of news or influencers in their community, and so they are likely to have the same attitude toward vaccination. They are either for it or they are suspicious of it and they are against it. And so you gain more statistical information if you take a small number of respondents per cluster and you go to more clusters. So typically we don't recommend more than having say 15 respondents per cluster, and we don't usually recommend having fewer than 5. There is a numerically optimal number. If you know the ICC, then you can calculate, and you know the ICC and you know the cost to go to each cluster, you can calculate the optimal number to calculate in each cluster. But we don't usually know the ICC. So, and we don't like to take the ICC or the design effect from DHS and mix. And that's because in DHS and mix, they usually have a very small number of children in each cluster who are the age that we're interested in, who have had their first birthday and not had their second birthday. In many clusters, actually, they will find 0 children who are in that age window, or they will find 1 child or 2 children or 3 children. And so the estimate that you get for design effect, or ICC, you can calculate a number, but it is numerically unstable. It's not unstable. It's not a great estimate of ICC to use for planning the next survey. It's fine to calculate it and use it for information purposes, but it's probably better to select a slightly more conservative value than what you get, because you're calculating a number using a very small sample size from DHS and mix, because they just don't have very many respondents who have had their first birthday but not had their second birthday. So it's okay to calculate it, but then I would select a more conservative value than that. How do I select these households within the cluster? That's a topic for later. We will cover that, but it'll be a little later in the course. So at this point, we won't discuss that in detail. The ideal sufficient sample size. The ideal sufficient sample size is going to vary depending on the goals of the survey and the resources. So there's no good one answer. There's no one answer to the what is the ideal sufficient sample size. Instead of pentavalent 3, can we take measles first dose? Yes, you can take whatever the committee thinks is the most important thing. They can take some they can discuss and decide what is the primary outcome, and then sometimes if it comes down to a choice between two, sometimes we pick the one that's closer to 50% because then that will give a good confidence interval for both. Another question, how do you figure 10 responses per cluster? What goes into it is thinking about how big a team am I going to have? How many days am I going to send them to the cluster? Are they going to be there for 1 day or for 2 days? How many households are they going to need to visit? And how many responses do I think they could reasonably do? How many children will they find, and how many interviews could they complete in a day? And then if that number is smaller than 5 or bigger than 15, then usually we have another round of discussion to say, okay, we probably don't want to do more than 15. We want to send people on to the next cluster. We want to pick more clusters. And if it's fewer than 5, then we say our questionnaire is too long, or our target respondents are too hard to find, and we're going to have to stay longer. Yes, can we classify coverage at the district level and measure point estimates at the national level? Yes, we'll get onto that. That's covered in the videos. And can we have a different purpose of the survey at district, province, and national level? Classify at the district level, point estimates at province and national level. Yes, so I do that all the time. That's a good thing. How do we plan the sample size calculation to meet all three purposes? So the point is that when you have different goals at different levels, if you think you're going to classify coverage at the lowest level and then roll up the estimates to estimate coverage at the higher levels, usually we do the sample size calculation at each level, and then we probably take whichever sample size will give us the biggest sample. And usually we calculate what will it take to meet the goal at the lowest level, at the most in this case, at the district level. And usually, if you meet your goal in the district level, you will also meet your goal at the regional and national level.